In this video, I am going to talk about the introduction to hypothesis test for proportion. So, what is a hypothesis test? A hypothesis test is a method of a statistical inference used to decide whether the data sufficiently support a particular hypothesis. For example, I flip the coin 50 times and get 75% head. Is this evidence that the coin is unfair? So, when we're talking about evidence, we're talking about statistical, if this statistical significance significantly support our hypothesis, which is the coin is unfair. So, assumption. Assumption is this is a fair coin. Okay, so that means for fair coin, you will have 50% of chance heads up. And then our hypothesis, when it comes to hypothesis test, our assumption we consider is a null hypothesis. We use the notation A sub 0. Since this is null hypothesis, the probability of this null hypothesis is 50%, 0.5. And what I want to prove is this is an unfair coin, which means it's significantly more than 50% heads up. Okay, so this we also call it, what I want to prove is called alternative hypothesis. We use the notation A sub 0. P, we want to prove that, hey, since you're getting 75% of heads up, we want to prove this is more than 50% or 0.5. Okay, how would a fair coin 50 times behave? So this means we need a sample distribution. And this sample distribution is going to build around the null hypothesis. Okay, so since we flip the coin 50 times, so that means our sample size n equals to 50. But right now, we don't know if we can use sampling distribution or not. Because in order to use sampling distribution, we need to check the central limit theorem. Okay, so central limit theorem is we need independence, randomization. These two is always checked. Since we are using hypothesis test for proportion, that means we need to check the success and the failure condition. Okay, n equals to 50, p is equal to 0.5. So this is equal to 25, which is greater than 10. Also, q also equals to 0.5, which means this is also greater than or equal to 10. So that means the success and failure condition, they check. That means the central limit theorem, check. So now, what will be our sample distribution of proportion model look like? Well, we know that this is going to be a normal distribution with the proportion p hat equals to the population mean, in this case is 0.5, and sigma hat is equals to p q over n. In this case, p is equal to 0.5 times 0.5 over 50, and then take the square root. So this is going to be our normal model. And why we want to build this normal model? Because we want this built around the null hypothesis. So that means the center of the normal distribution is going to be our null hypothesis, which is 0.5. And then 1 standard deviation, 2 standard deviation. Okay. So where does my sample land in comparison? Does it have a high or low probability of occurring? So when we say probability is small, means the p-value is small. So in a normal distribution graph, you're looking at, look, you have a 0.5. Oh, sorry. So that's the null hypothesis. And what we get is 0.75, right? Let me find out what is the sigma equals to. So this is equals to 0.0707. So that means our standard deviation, our model is look like 0.5707. And then the second standard deviation is going to be 707 and 0.6414. So now our result, what we get is we got 75% of heads up, right? So that means 0.75 is going to be here outside of the 2 standard deviation, approximately here. So this part is going to be our p-value. The highlighted part, everything greater than 0.75, what we get is our p-value. Okay. So now, how do we define that the probability is small or probability not small? Well, if the probability is small, that means our sample was unlikely under the assumption. So that means, what's our assumption? Assumption is this is not a fair cone, right? So that means this is not unlikely under our assumption. Our assumption is this is not a fair cone, so that means our assumption is this is a fair cone if it's not unlikely under the assumption, so that means this is not a fair cone. So this is statistically significant. So in that case, we are going to reject the null hypothesis, and we will say there is evidence for the alternative hypothesis. So that determined by the p-value. If p-value is small. Okay, on the other hand, if in our case, what is probability is not small? If probability is not small means, well, under your normal model, again, we build around the null hypothesis. Let's say if 0.75 is in here in 2 standard deviation, so the highlighted part, the highlighted area is going to be our p-value, and p-value is not small, means the probability is not small. So in this case, we will say, hey, our sample was somewhat likely under the assumption, which is our null hypothesis. It's statistically significant. So, which means this is a fair cone. We have failed to reject the null hypothesis and not sufficient evidence for our alternative hypothesis. Okay, So now let's take a look. How do we set up the null and alternative hypothesis? So early, as we say, the null hypothesis is our assumption. Our assumption is, hey, this is going to be a fair coin. So if it's a fair coin, this has to be 0.5. And then our alternative hypothesis is something that we are trying to prove, which is P is going to be greater than 0.5. So for the central limit theorem, it's the second step, because after you satisfy all the central limit theorem, then we can apply the sampling distribution to test out our hypothesis. So for the central limit theorem, we have independence, randomization. The last one is the success and the failure condition, which means the sample size times the success rate has to be greater than 10, and the sample size times the failure rate, which is 1 minus p, it has also to be greater than 10. And we check that since our sample size equals to 50, p equals to 0.5, so NP greater than or equal to 10, and Q also greater than or equal to 10. The third step is we build the sampling distribution and calculate the test statistic. So there's two ways to do it. One way to do it is we build a sampling distribution of proportion normal model for that, which means our mu sub p is equals to our population p, which is 0.5, and our sigma sub p is equals to p times q over n, which is 0.5 times 0.5 divided by 50. In this case, it's 0.0707. And then we can build a normal distribution. This is sampling distribution of proportion. Another way to do it is to have a test statistic. What is a test statistic? This is the second method. I'm going to use a right hand. Okay, so that means I need to find the z-score for what we have. So the z-score equals to our p-hat subtract our population mu divided by sigma. In our case, our p-hat is, since you got 75% heads up, so I have a 0.75 subtract our mu 0.5 divided by sigma p-hat, which is, this should be mu hat p-hat, and this is equal to 0.070, which you got a z-score equals to 3.5361. So what does z-score for? Remember that z-score follow a normal distribution with the mean equals to 1, sigma, which is standard deviation, equals to 1, mu equal to 0, sigma equals to 1, and now you got the z-score is 3.5361. That looks like very big, so it's less likely. So if you have the z-score normal distribution on your GeoGebra, it should look like something 0, 1, 2, 3, and your z-score is 3.536, so something outside of 3 standard deviation. So this is going to be your p-value if you use the test statistic. Okay, so now how do we calculate the p-value? Well, this is how we do it if you use test statistic. Now, if we use our sampling distribution of proportion, when we calculate our p-value, we have our proportion follow a normal distribution with the mean is 0.5, sigma is 0.0707, and then in GeoGebra, you're going to find that in GeoGebra, we have 0.5, first is 0.707, the second is 0.6416. And now we're trying to find out the p-value. When p equals to 0.75, which is in here. So we're trying to find the probability when the p-hat is greater than 0.75. What will be the probability of this proportion? Let's check that with our answer. Okay, for the first method, we have mu equals to 0.5 and sigma is 0.77, and we want this to be x greater than 0.75. So what we get is 0.0002, which is less than 0.2%. Now, let me write this down. This is equal to 0.002, which is 0.02%. Now, what if we use z-statistic? Now, let's check this again. For z-statistic, our mu is equal to 0, and the sigma is equal to 1, and then we want our x is greater than 3.5361. Again, the result is the same, also equals to 0.002. That means no matter which method you're going to use, you will end up to have the same result. Okay. For the z-statistic, we have a p, which is our z-score greater than 3.5361, also equals to 0.0002. So what would be our conclusion? Well, with these two methods, we got the p-value is very small. If we have a small p-value, that means we have a small probability, we're going to reject the null hypothesis with our p-value 0.0002. There is an evidence that cone is unfair and so has significant more than 50 times. That's how you use hypothesis test. Well, that's it for the introduction. Next time we will discover more about hypothesis tests.